As we contemplate the sun, we are aware of its enormous power and the energy it emanates throughout our solar system. It is hard to imagine anything capable of surpassing our sun, yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. The red supergiant defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. The star is an enigma to scientists who are still studying its power and potential as they investigate this magnificent star in depth. They have discovered something terrifying. Join us on this tour as we dwell into the constellation Orion with the James Webb Telescope and explore how its arrival could change our understanding of the route and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification. Though many people are unaware of this fact, it is possible to spot B Rouge in the night sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellations Orion and C's Major to see this dazzling star in all expel. There you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at the star, you will have noticed that it does not remain constant. In fact, varies in brightness periodically. This peculiarity is no coincidence, since Vito Rho, as the star is called, is no ordinary star. Although to us it may appear just to be one more in the vast firmament, is located at a distance of more than 640 light-years from us. At first glance, this figure may not seem impressive, but in reality, it represents an enormous distance. To illustrate this magnitude, let's imagine that we could travel at the speed of light, which unfortunately is not possible. Even in that hypothetical scenario, it would take us more than 640 years to reach VO. If we wanted to undertake such a journey in a spacecraft, even using our most advanced technologies, it would take us more than 12 million years to reach it. This figure far exceeds the entire history of human civilization on Earth. However, the scarcity of light from Vito is not only due to the distance that separates us from it. Vito is what is known as a pulsating red supergiant, which means that it is an ancient massive star that undergoes expansions and contractions. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods, ranging from tens to hundreds of days. The amazing thing is that Vouch can oscillate in brightness over a wide range. It can range from near magnitude 0.5 to reach 0 magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest being 2,335 days. At times VTO Rauch can become quite faint, which is called van magnitude. In February 2021 it was reported to present its lowest van magnitude in a long time, reaching magnitude of plus 1.614. Although it is relatively bright, it is definitely fainter than how we usually observe you. However, brightness is not the only outstanding feature of the star. B Rouge is known for its distinctive reddish color, which is due to its cool surface, which has a temperature of about 3,500 Kelvin. The temperature is much lower than the surface of our sun, which reaches 5,500 Kelvin. This lower temperature means that VR emits much less energy per unit area compared to the sun. That is why, despite being one of the largest stars, we know it appears much dimmer. Verge is like that giant that is satisfied with a low profile and doesn't need to show off its size to feel important. However, don't be fooled by her appearance. Lurak is a supergiant star that is about 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies over the centuries. It has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Ptolemy. His name in Arabic means Orion's armpit, but not much could be known about Viru at the time. Modern telescopes have enabled researchers to study this phenomenon in greater detail. By analyzing the light emitted by verge, astronomers have been able to determine many of its properties such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Verit's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. But has also been studied using the Atacama Large Submillimum Array, or acronym ALMA, a state-of-the-art observatory located in Chile. ALMA has provided high-resolution images of the surface of Roche, revealing details about its structure and behavior. One of the most remarkable discoveries made by ALMA is the presence of an extensive plume of gas extending from the surface of the star. This plume is believed to be caused by pulsations from Veru. The pulsations can be explained by a process called convection, involving the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to the Hubble Space Telescope, detailed images of Veru's surface have also been obtained, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict how it might behave in the future. In addition, Veru's surface is marked by dark spots, also known as star spots or magnetic spots. These areas on the star's surface exhibit particularly strong magnetic intensity. These regions, known as star spots, are areas on the surface of VTO Rouge that are cooler. This is because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. As a result, the spots appear darker compared to the rest of the surface. Viewers' magnetic field is believed to be thousands of times stronger than that of the Sun. The intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, describing regions of intense magnetic activity that are visible as star spots. It is important to mention that the presence of star spots is not unique to V2. They're also observed in other stars, including our own Sun. The star spots in Voter Rouge are very specially interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is significantly larger and more numerous than the sunspots on the Sun. These star spots can affect the overall brightness of the star and cause variations. As the spots move in and out of view, Valericus brightness can fluctuate. This is because the spots, being cooler, emit less light than the surrounding gas, which contributes to changes in the observed brightness of the star. In the case of Roche, pulsations of the star also contribute to the brightness variations. As the star expands and contracts, star spots move in and out of view, further amplifying the star's observed brightness. The surprising thing is that V Rouge is not as unique as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. One of Rouge's cosmic cousins is Antae, a red supergiant located in the constellation Scorpius. Antae is also a variable star, meaning that it undergoes changes in brightness over Time just like Boo. In addition, and has a mass approximately 12 times that of the Sun and a radius that is 700 times that of the Sun. So it's safe to say that Antares is no slouch in terms of size. Now, what do you think? Do you think Vidro has already exploded and it's just a matter of time before we see it in our skies? Let us know in the comments box. If you like the video, like and subscribe to the channel. Thank you so much for watching. See you soon. One of the most pressing questions about Vito Rho is whether it's approaching the final chapter of its stellar life. Supergiants like Vito Rho are massive stars nearing the end of their life cycles, and it's widely believed that such stars explode in a violent supernova. This cataclysmic event releases an unimaginable amount of energy, briefly outshining entire galaxies. Scientists suspect that Vito Rho might be nearing this explosive. The unusual dimming events in recent years, particularly the great dimming of late 2019 and early 2020, caught the attention of astronomers. Worldwide. For a time, Vito Rho became significantly dimmer, sparking speculation that the supernova might be imminent. However, further studies revealed that this dimming was not caused by a supernova precursor, but rather by a large cloud of dust ejected from the star itself. This finding, while not as dramatic, was still groundbreaking as it helped refine our understanding of how massive stars lose mass in the years leading up to their. So, let's say it did explode. What would that look like from Earth? First of all, there's no need to worry. Vito Rho is far enough away at about 640 to 700 light-years that its explosion would not pose any threat to Earth. Even at its brightest, the blast would be harmless to life, but incredibly visible to the naked eye. If it exploded, scientists believe it would become so bright that it would be visible in the daytime sky for weeks, possibly even at night. It would outshine the full moon. The visible aftermath of the supernova, called a supernova remnant, would linger in our skies for years, possibly centuries. For astronomers, a nearby supernova like this would be a once-in-a-lifetime event, offering real-time data on stellar explosions, black hole or neutron star formation, and the creation of heavy elements in the universe. After a red supergiant like Vito Rho explodes, what remains depends on the mass of its core. The core is below a certain threshold, collapses into a neutron star, a dense object about the size of a city, but with more mass than the Sun. If it's more massive, it may form a black hole, warping space-time around it and swallowing anything nearby. For Vito Rho, either outcome is possible. The mass is near the tipping point, so scientists aren't sure which path it will take. That's why continued observation is so important. Multiple observatories around the world and in space are constantly monitoring Vito Rho. The Hubble Space Telescope captures high-resolution images of its surface and the dust swirling around it. The ALMA array in Chile peaks into gas layers ejected from the star, while the James Webb Space Telescope offers unprecedented detail in the infrared spectrum, allowing astronomers to see through those dense dust clouds. Ground-based telescopes like the Very Large Telescope, VT, and others also track its brightness, motion, and spectral changes regularly. All of this data combined gives us a clearer picture of the star's behavior and possible future, while other red supergiants such as Antares or Musfafai are also enormous and intriguing. Vito Rho holds a unique place in the sky. It's one of the closest and most massive stars of its kind, making it a perfect laboratory for studying the physics of massive stellar evolution. It's not only massive, but also wildly unstable, showing unusual variability, dust activity, and surface changes. Sheer size is mind-boggling. Place at the center of our solar system would engulf everything out to Jupiter's orbit. Yet despite its grandeur, it remains a faint flickering ember in our night sky. Mysterious and powerful, but still cloaked in cosmic mystery.